Welcome to part 2 of section 4.6 for Math 3. We're looking at Descartes' rule of signs. Just so you know, Rene Descartes was a mathematician who did, well, lots of things. But if you ever heard of the words Cartesian coordinates, that's named after him. Cart, yeah. Anyways, so Descartes' rule of signs is a way of looking at a polynomial and trying to determine how many possible positive real roots there are, how many negative real roots there are, and by process of elimination, how many of them are going to be imaginary. Okay, so let's start with the maximum number of positive real roots. First of all, you have to have a polynomial and it has to have real coefficients, so the coefficients can't be imaginary, and it has to be in standard form for this to work. So the maximum number of positive real coefficients is equal to the number of sign changes. So think from positive to negative or vice versa. That's a sign change. So that's changes of sign from one term to the next, moving from left to right of your polynomial. Now that's the maximum number, but you can get other possible numbers of positive real roots by reducing that number by multiples of 2. Okay, so let me skip the rest of this to show you an example of what we're talking about. Okay, so here we have a polynomial. It's equal to 0, or it could just be equal to y. If it's a function, it works the same either way. And everything's in standard form. And what you want to do is you want to go from left to right and look at the sign changes. So here, this is a positive, and then this is a negative. So this is one sign change from here to here. All right, then we have a negative to a negative, doesn't change at all. Then from a negative to a positive, it changed again. Okay, then we have a positive to a negative, it changed again. So we have 3 sign changes. Okay, and so that means there's the maximum number of positive real roots could be 3. Okay, so one way to organize the data that we're going to do is by making a chart. And we're going to have one column for positive, one for negative, and then we're going to have one for imaginary. So I'll use an I for imaginary. So there could be 3 positive sign change, or 3 sign changes means 3 positive roots maximum. But it doesn't have to be 3. It could be less than 3, but it has to be by reducing it by multiples of 2. So I could subtract 2 from 3, and there could just be 1. Now I can't go any further because that would give me into negatives, and that doesn't make any sense. Okay, so now we're going to find the maximum number of negative roots. So to do that, we have to substitute the x with a negative x and then repeat the process. Count the number of sign changes. But we have to substitute this negative x for x first. Then you do the same thing. You reduce the number by multiples of 2 to get other possible numbers of negative real roots. So this is negative roots. Okay, so let's try this. First we have to take all the x's out and plug in a negative x. So I'm going to 2 times negative x to the 4th minus negative x cubed minus 4 times negative x squared plus 3 times negative x minus 1. So when you're doing this part, it's helpful to keep in mind that a negative to an even power is just going to cancel. So this is going to go back to being 2x to the 4th. It didn't change. Alright, so that's wherever you see a negative x to a even power, just think that negative is going to cancel, so it's not going to change. So this is going to remain right here, negative 4x squared. Now, when you have an odd power with a negative, it will change. A negative x cubed will be negative. And because it'll be a negative and another negative, this will turn into a positive x cubed. So this sign will change because of that. And then over here, well, this is odd. This is a 1. But it's a little easier to see that, yes, that's going to change to a negative 3x. And then the constant doesn't change. Now we repeat the process of looking at how many sign changes do we have. Okay, we have 2x to the fourth to positive x cubed. So this goes positive to positive. Then we go positive to negative. That's a sign change. Then we go negative to negative, stays the same. Negative to negative, stays the same. So there's only one sign change. That's the maximum number of negative real roots. Okay, so where does that fit in? Well, if you pay attention to the degree is 4, and that tells you the number of roots. Okay, so over here, or to our chart here, if we have 3 positives, we could have 1 negative. That's a total of 4. So there wouldn't be any imaginary, right? Because they have to add up to 4 total, the degree. Okay, I can't subtract. If this was like a 3, just like before, I could subtract 2 and get just 1. But I can't, remember you have to subtract multiples of 2. But I can't subtract 2 from this, would be negative. So in the case, remember I could possibly have just one positive real root. Then maybe I can still have one negative. But that only gives me 2. So then maybe there's 2 imaginary. This is another possible case. I don't think your homework is going to ask you about the imaginary, but I'm just throwing that in there just because it kind of ties in really well. Remember in the last video we talked about how imaginary roots always come in pairs? So imaginary will always be even, an even number, always. So kind of keep that in mind. Okay, how about let's pause the video and I want you to try B on your own. At the very least, just count how many sign changes for positive and for negative. Okay, so for positive there was a maximum of 4 because it was 4 sign changes. So I wrote down 4, but then remember you reduce it by multiples of 2. So subtract 2, you get it. There could just be 2. Subtract another 2, there could be 0, and that's as far as you can go. So then I plugged in negative x for x, and we had some things change, right? Remember, if it's an odd exponent, the negative is going to basically come out here. If it's an even exponent, then the negative is just going to disappear because it cancels. So when I did that, I got negative 2x to the fifth minus 6x to the fourth minus x cubed minus 7x squared plus 8x plus 9. So we get like 4 negatives in a row. Then it switches to a positive. So we had one sign change right here, and then it stayed positive. So there was only one possible negative root. Okay, so let's think about the imaginary. So the degree is 5, which means the number of roots has to add up to 5. So if we have 4 positive and 1 negative, that's 5. So there's no imaginary. We could have 2 positive, and we could have 1. Remember, you can't really subtract 2 from 1, so it's just going to stay 1 the whole time. That's pretty much it. Okay. Alright, so then going back to the amount of imaginary, we could have 2 positive, 1 imaginary, or 1 negative, which leaves us with 3, so there could be 2 imaginary that left. If there's no positive, 1 negative, that leaves us with 4. Remember that this will always be an even number. Okay, so those are the possible combinations of roots that we can have. These 3 combinations of positive, negative, and imaginary. Okay, So now let's put force 6 all together. So now I want you to try all of these 3 questions on your own. And there will be an answer key for you to check later.